As she said, my name is Aubrey Cloud. I'm Restoration Project Manager at the Luckiamute Watershed Council. I want to thank you all for coming out tonight, for braving the early dark of winter to come see this talk. I am really excited about this, and we have a lot to cover. So if you don't mind, we're just going to jump right in. Woo! Woo! So, stop me if you've heard this before. We're living in unprecedented times. It's true, we definitely are. I'll leave specific examples to your own recollection, but for me it's definitely felt like a wild ride these last few years. But the thing is, we've been living in unprecedented times for a very long time. Every generation has its own unique set of unprecedented challenges and upheavals that it has to contend with. And the field of ecology and land management is no different, and that's the subject of our talk tonight. In the circles of ecology, there's a quote by Aldo Leopold that often gets used in reference to this phenomenon. And because I would butcher it if I tried to recite it from memory, I'm just going to read it. And that is, one of the penalties of an ecological education is that one lives alone in a world of wounds. Much of the damage inflicted on land is quite invisible to laymen. An ecologist must either harden their shell and make believe that the consequences of science are none of their business, or they must be the doctor who sees the marks of death in a community that believes itself well and does not want to be told otherwise. Now, this quote is most often wheeled out in reference to relatively recent losses. Million-strong herds of bison that used to thunder across the plains, or flocks of passenger pigeons that were so large they would literally block out the sun and take hours to pass by. And these are all very valid and consequential losses, but extinctions are not a new phenomenon. They did not begin with the industrialized era, though that has certainly accelerated them. They began almost 12,000 years ago at the end of the Pleistocene epoch. They began with the loss of most of the world's large terrestrial megafauna. Now, when we peer back into the past, it can often seem exotic and strange. It can defy our modern sensibilities about what is normal. But what is really important to remind ourselves of is that today is the abnormality. Right now is the thing that is profoundly weird from the Earth's perspective. Large, huge animals have been a staple of terrestrial ecosystems for at least 300 million years. Life evolves to fill vacant niches or roles within an ecosystem, and one of those roles is that of the megafauna. It's only very recently that we've lost them. And real quick, before we go on, let's define that term because I'm going to be using it a lot tonight. Megafauna technically refers to any animal that weighs 100 pounds or more. Technically, that means that things that are still around are megafauna. Things like deer and most humans. You are a megafauna. Congratulations. But in the popular imagination, it's often understood to mean an animal that weighs a ton or more. For the purposes of tonight's talk, we are using the technical definition, but a lot of the animals we're going to meet happen to also qualify for the 1-ton category. But if we stuck to that, it would leave out a lot of animals that I consider pretty big, things like lions and tigers. And that, speaking of, Africa and parts of Southeast Asia are today the only parts of the world that retain anything like a diverse, intact megafaunal assemblage on their landscapes. And for that reason, those places also get exoticized. But again, that used to be normal. That was literally everywhere that wasn't buried under 2 miles of ice. And tonight we are going to be meeting the megafauna of the Willamette Valley during the late Pleistocene. And the reason that we're going on this little time machine journey is twofold. One, megafauna are awesome. Like, it really doesn't need to be any more complicated than that. A lot of ecologists will kind of grumble that everyone loves these large charismatic animals and not enough people love beetles and worms and stuff. That's a valid criticism, but at the same time, there's a reason people love these things. They're awesome. And fostering that love of nature and place is really important because you can't protect a thing if you don't love it. Secondly, these animals vanished moments ago from an evolutionary perspective. In the eyes of the Earth, they were here just a moment ago and now they're gone, and that has real consequences that are still being felt today in our modern ecosystems. Life today evolved together with these animals, and those relationships are now missing partners. Our world is haunted by their absence, and that's what we're going to explore in the back half of this. So, that brings us to the Willamette Valley. When I first made this talk, I had intended to set the stage a little bit and give us a little flyover of the Pleistocene world at large, give you a taste of all the weird, wild, and wonderful animals that were alive then. I had to cut that for time, but just trust me when I say it was wild. 20-foot monitor lizards, terrestrial crocodiles, multiple species of humans, including real-life hobbits, storks that were as tall as me and the top predators in their ecosystems, and 24-ton elephants that were the largest land mammals that have ever lived. The world was teeming with things that seemed like they belong in a Lord of the Rings movie, but they were all real, and humans met all of them. And we're about to meet the ones from the Willamette Valley. A couple quick disclaimers before we dive in. I'm not a paleontologist. I'm a restoration practitioner who appreciates the intersection of my work with this subject, and I'm just a super fan. So I'm going to be reporting on the work of paleontologists who know what they're doing. Apologize if that causes me to stumble in the Q&A section later. And as Suzanne mentioned earlier, most of tonight's talk will be focused on the last 20,000 years or so. We know for a fact humans have been here for at least 15,000 years. Because of time constraints and my own lack of knowledge on the subject, tonight's focus is mostly focused on megafauna that will only tangentially intersect with the human component later on. But it's important to remember that just because I'm not talking about them, they were here and they would have been a really important part of this landscape and ecosystem. Okay, so the Pleistocene, I've been using that word a few times. What is that? What does that mean? Some of you may already know, but just to get us all on the same page, it is a division of geologic time. Specifically, it is an epoch. Geologic time is divided into several categories, and you can think of them all as buckets of time containing smaller buckets, and each of those smaller buckets contains more smaller buckets. So for example, we are now living in the Cenozoic era, which is everything since the end of the non-avian dinosaurs. And we are living in the Quaternary period, which contains two epochs, the Pleistocene and the Holocene. The Pleistocene began about 2.6 million years ago and ended almost 12,000 years ago. Ever since then, we've been in the Holocene. That is our current epoch, depending on who you talk to, but that's a whole different talk. So you may have heard the Pleistocene referred to as the Ice Age. That's a more popular term for it. That is an accurate term, but it's not the full picture. Technically, the Quaternary is an ice age. We are living in an ice age, the fifth one in the entire history of the Earth. We are still in an ice age. We just happen to be in something called an interglacial period. So the massive ice sheets that would spread out and cover, half a continent at a time, they've receded, and we're in kind of a warmer version of that time. Ice ages, once they're triggered, are influenced by an astronomical phenomenon called Milankovitch cycles. All that means is that other planets and things in the solar system are still exerting a gravitational pull on us. And so that causes irregularities in our orbit as we circle the sun. And those happen in regular cycles. And that changes the amount and angle and direction of sunlight that's hitting the Earth. And so that causes these periods of glacial expansion and ice sheets like what you see in Antarctica covering half of North America, for example. This is an example of what the world would have looked like at a glacial maximum, which is the maximum extent of one of those ice sheets. Those ice sheets could be 2 miles thick in places, and they would lock up so much water that the sea levels would drop by over 300 feet compared to modern levels. That had drastic effects on what we consider to be normal geography. The UK, Japan, and most of Indonesia were all connected to mainland Eurasia as part of one massive, enlarged continent. Tasmania, Australia, and New Guinea were all connected as one large continent called Sahul. And there's countless other examples, like fundamental geology was altered. I have a question from the audience here. He's asking why there weren't ice sheets in the southern hemisphere, and I think it's because of the tilt of the Earth, which is one of those factors that's affected by the Milankovitch cycles. I'm not an astronomer, even more than I'm not a paleontologist. I could not describe the mechanics of it to you, but basically shifts in the tilt of the Earth would affect that, and basically the southern hemisphere would be tilted more towards the sun. It's more complicated than that. I'm not the right guy to explain it. Sorry. So here in the late Pleistocene, what was it like right here? For starters, we were never under ice. The ice sheets never quite made it this far south, but they did make it close, like to the Puget Sound. David Orr, professor who, along with his wife, literally wrote the book on fossils in Oregon, has characterized the Willamette Valley as basically one big wetland during the Pleistocene. A lot of almost flat gradients, slow-moving rivers and braiding side channels and stuff, fed by all these watersheds, which our council represents one of now. But of course, there was variation in topography, and there were higher spots that were dominated by other vegetation. There's a big study in 2014 that did a bunch of fancy science techniques, and they tried to kind of characterize the general plant regime in the area. And they found that from about 16 to 14,000 years ago, it was a big grassland, really open habitat. And that slowly started transitioning from then to the end of the Pleistocene, first to a mixed grassland and open forest system, and then finally to a closed forest. And we know that changed again due to indigenous fire management in the Holocene, which opened it back up into grassland and savanna systems. And the valley was also, not for that whole time, but for a couple thousand years, periodically influenced by some truly catastrophic cataclysms. Some of you may have heard of these. These are called the Missoula floods. Basically, at the maximum extent of these ice sheets, one of them right here on the border of Montana and Idaho basically blocked off a big basin behind it and it created a natural dam. Water started filling that basin from glacial melt and regular precipitation, and eventually it would get so big it was bigger than Lakes Ontario and Erie combined. The ice dam was enormous, 31 miles wide, 2,000 feet tall, but ice is less dense than water. So when the lake filled up to a certain point, the dam would start to float, water would start gushing out, break up the dam, and it would just tear through eastern Washington down to the Columbia Gorge and out to the sea. The Willamette Valley was not in the direct flood path, but we acted as a massive catch basin for these floods. So it's unlikely that we had like massive tsunamis like rushing up the valley, but it would have been really quick, high-rising, catastrophic floods. This happened at least 40 times over, it would be repeated cycles of the ice dam forming, the lake filling, the dam bursting, etc. I've read a few different things that say between 2,000 and 7,000 years was the period that this was going on for, but it would have been a regular force influencing the valley. Now, onto the megafauna. Because those conditions I just described are really conducive to preservation and fossilization, because this is the most populated part of the state with a lot of people just stumbling onto things, we actually have a really good idea of what is here. We found a lot. We also have the efforts of a few really dedicated individuals to thank for that. One of them is here with us tonight. That's Mike Full over here. He brought the fossil replicas, which you should definitely check out before you leave. He's been hunting fossils on the Yamhill River since 1962, and that dedication has really paid off, as we're going to see later tonight. Another one who deserves special mention is Dave Ellingson here. He's a science teacher at Woodburn High School and is responsible for really leading a lot of efforts there that we'll see later on as well. And real quick, these fossil sites that we're going to look at and discover, only one of them actually occurs in the Luckiamute Watershed. But because the rest are our neighbor watersheds, and because of how big these megafauna are, you can safely assume that anything that we talk about tonight would have occurred in the Luckiamute Watershed as well. But the first one was here, and it was not only here, but it was in Kings Valley, which is a place where the council does a ton of restoration work. We have great relationships with so many landowners up in that region. And they found a really amazing fossil site up there. So it's like everything I love in one place. In the late 2000s, a landowner was excavating some cattle watering infrastructure in a natural spring, and he struck scientific gold. He found fossils. David Orr, who was pictured earlier, and Mike Full were called out to lead some digs from 2009 to 11, and they found a lot of really cool stuff in this old bog. Some stuff that's still here, like coyotes and modern beavers, but also some stuff that's not, like Columbian mammoths, ancient bison, which is the direct ancestor of modern bison, except it was like 25% bigger. One of our replicas is the skull of it over there. It's absolutely enormous. You should check it out. But the star of the show was this amazing animal called Harlan's ground sloth. Ground sloths were the weirdest and the coolest animals that you've probably ever seen. They are just amazing. They actually originate from South America, just where we still find tree sloths, which are their surviving relatives today. They were probably the most successful colonizers of North America during an event called the Great American Biotic Interchange. And what that big long term means is when the Isthmus of Panama was formed about 3 million years ago, these continents were joined and all their wildlife started exploring the other continents. South America had been completely isolated since the asteroid took out the dinosaurs, and so just the weirdest life forms started evolving there. The ground sloths were the most successful group that came up to North America. We know of at least 5 genera that lived in the continent during the Pleistocene. Some of them were absolutely enormous. We're talking 20 feet long and weighing 4 to 6 tons. Ours that we found here, the Harlan's, was about 10 feet long and maybe a ton. So it was a medium giant ground sloth. They were just so bizarre. Unlike every other animal on Earth that walks on like the palms or the soles of its feet or their toes, this thing walked on the sides of its hands and feet, and it would just waddle around, and it must have been the most awkward sight you've ever seen. And they had these massive, very dangerous claws that were probably adapted for digging and burrowing. So all the sloths were weird. Ours was even weirder. Certain lineages of sloth had these little discs of bone called dermal ossicles, which were not part of their skeleton. They were embedded in their skin, and that was under their fur. So it's kind of like crocodile armor, except it was under their fur in their skin. And this acted as a natural like chainmail coat, like some armor that would protect it from predators. Ours had it, and they found a ton of them at the Kings Valley site. And then another really weird thing that was just published on a couple years ago, certain lineages of ground sloth were not just herbivores like most of them were assumed to be. One lineage, the Mylodontids, of which ours was a member, was discovered to be omnivorous. They needed meat in their diet. I have trouble picturing this thing running down deer, but it was likely a very effective corpse bully. It could waddle up on a kill or natural death of an organism that had died somewhere else in the landscape. And these things were so powerful, nothing probably would want to mess with them, and they could just bully them off the carcass and eat their hearts out. And another really interesting, and this, I have to emphasize, this is pure speculation on my part, but one thing I like to imagine here in the Pacific Northwest is that after salmon runs, these things would be waddling out into the streams and splashing around, feasting on dead fish that would have been everywhere here. There's been no studies on that, so that's just my speculation, but yeah. All right, next up, some of you may have heard of this. OSU in 2016, it was in the news. Construction workers expanding Reser Stadium stumbled upon some fossils during their work. So Dr. Lauren Davis from OSU was called in to lead the dig. Mike Full and Dave Ellingson from earlier were called down to help, and the construction was only paused for a few days, so we don't know everything that would have been down there, but before construction resumed, they did get out remains of more of that giant ancient bison we were talking about. The American camel, Camelops, that's right, we had camels. Not only were camels native here, but they first evolved in North America and then spread out to the rest of the world from here. Of course, this thing was massive. It weighed a ton and stood 7.5 feet tall at the shoulder. It was ginormous. But the big news at this one was the Columbian mammoth remains they found. And this is a good opportunity to talk about the mammoths and mastodons because both of them were present in this system. We did not have woolly mammoths. Those were restricted to northern latitudes. This was a different species called the Columbian mammoth. Columbian mammoths were wide-ranging all over the continental US and down into Central America. They were incredibly successful. And even though they were not woolly mammoths, they were elephants. All mammoths are part of the family Elephantidae, which means that mammoths are technically elephants. Asian elephants are the closest living relative of these animals, which also means that Asian elephants are more closely related to mammoths than they are to African elephants. And these things were enormous, 13 feet tall at the shoulder, 11 tons, which means they were as big as the very largest African bush elephants today. In contrast to that is the shorter but more robust mastodon. Now it looks very similar. It's a proboscidean, which is that group of animals with the long snouts and giant tusks, but it's actually a really ancient lineage. These animals diverged from mammoths and elephants 25 million years ago, which for context is about 5 times longer further back than humans and chimpanzees diverged. And they inhabited very, very different ecologies. They weren't in competition with each other. Mammoths were grassland grazers, whereas mastodons were browsers in woodland ecosystems, primarily. And we know this because of a diagnostic feature that is really helpful to tell them apart. Hopefully, just by looking at them, you can spot a few differences. If we had more time, I'd go over a few of the kind of superficial ones. But really the diagnostic one that is super useful because they preserve really well is the tooth morphology. Teeth in general are great for identifying mammals, and especially so in mammoths and mastodons. This is a mastodon tooth up here. It looks a lot more like a classic molar with those raised cusps. It's great for breaking up and processing woody vegetation. This is a mammoth tooth, and it's made up of these tooth plates that are all glued together, and they're made for grinding down grass. Grass is full of silica, which is an incredibly abrasive substance, and it just does hell on the teeth of any animal that's unfortunate enough to eat it. And so these tooth plates would feed up kind of like a deodorant stick till they'd all been expended, and the tooth would fall out, and then a new replacement tooth would take its place. And mammoths had about 6 sets of these that they would go through throughout their lives, and if they ran out, they'd probably starve. There are replicas of a mammoth and mastodon tooth in the back, and I encourage you to check those out before you head out. So this, real quick, this is just a visualization of how far back mastodons and elephants and mammoths separated. They're really, really not very closely related. And it doesn't even end there. There's entire other branches of proboscideans that branched off between there that they had surviving members up until the end of the Pleistocene. And the point of this is not for you to remember all of these. I'm not going to quiz you on it. The point is to drive home just how wildly diverse and successful these animals were. They were absolutely everywhere. There were tons of them. The only places they didn't get to were like Australia, Madagascar, and Antarctica. Incredibly successful and diverse animals. Woodburn High School is our next stop, and it's really actually a complex of sites up in Woodburn along Mill Creek that runs next to the high school. These were first identified as fossil-bearing sites in 1987, another accidental discovery during sewer line repair work. And it's a series of basically old Pleistocene bogs that have preserved a ton of material. Originally it was more megafauna that were discovered, and scientists were called in and a lot of work was done. Today there's annual digs that happen every summer, and you can sign up and join in on them. Sounds really fun. But it's not just megafauna. One of the most common fossils found at this site is the northern leopard frog, which is an animal that is still alive today. But it's not in the Willamette Valley. We have 3 frogs in the valley today: the Pacific chorus frog, northern red-legged frog, and the invasive American bullfrog. This animal's not here. This is its range in the modern day, and the lighter red polygons on the map represent range contractions since the 1970s. That's habitat that it's lost. But even then, it never quite reached the Willamette Valley. And this is really fascinating because it tells us a lot that we wouldn't otherwise know about the ecosystem in the Pleistocene here. We know the life history of these animals, and that can help us identify certain things about the system. For example, they overwinter in cold but clean pools of water that don't freeze solid. So when they were present, it was never getting so cold that the water was freezing, things like that we can learn from this. And I'm really excited about these because maybe there's some restoration potential in the future. It would be really cool to do some research and find out why these animals are no longer here. And Pleistocene rewilding is an actual movement in restoration, and there may be applications of that here. I'm not recommending we go catch and release a bunch of leopard frogs. Let me be clear about that. There would be a lot of science required before that's done. But these are interesting possibilities that we would never have even known existed if it weren't for these discoveries. And it's not just the leopard frog. There's a ton of modern animals that are still alive that just don't exist in the valley anymore. things that have been discovered at Woodburn or on the Yamhill River include sandhill crane, sharp-tailed grouse, bighorn sheep of all things, pronghorn, the bison that we've been talking about, and then even plants like mountain hemlock and Engelmann spruce. But there have been megafauna found at Woodburn, and one of them is probably my favorite of like the entire menagerie. And that is a species entirely new to science that's known from nowhere else on Earth. And that is this big boy right here, Teratornis woodburnensis. That is its scientific name. It was discovered in the late 90s. Close, yeah. He was asking if it was a vulture, and it is close. So this is an absolutely enormous predatory bird. It's known from nowhere else. It was published on in the early 2000s, and this is the only art I could find on the entire internet representing it, because it's still pretty unknown popularly. But it's a really useful one, because here you can see it here compared to, for example, the California condor, our current largest bird, with its puny 10-foot wingspan. Might as well be a pigeon. This thing was enormous, a 14-foot wingspan. It was just the coolest animal. They were, as was said, related. They're a sister family to condors and New World vultures. It's believed that they filled a similar but slightly different ecology than those scavengers. They probably were wide-ranging scavengers, especially of large megafauna carcasses, but studies have also shown that they were probably capable of actively hunting small prey like rabbits and things like that. So that's probably my favorite thing of all of this, and it's huge. Probably not big enough for anyone here to ride, but I mean, I don't know, a hobbit might fit. Okay. The Yamhill River, which flows through McMinnville. Mike Full, again, who's with us tonight, has been hunting fossils on this river for over half a century, and he has found a lot. He's made a lot of really amazing contributions. 18 different mammal species, including everything we've talked about so far, plus some like wild horses and large-headed llamas. That's right, we didn't just have camels, we had llamas. And right here, they found an entire mammoth eroding out of the riverbank, and they did a whole excavation on it. It's called the McMinnville Mammoth. Really, really cool stuff. But by far, the biggest news that has come out of this particular section is the giant beaver, Castoroides. The beaver state has a giant beaver. This is a known species, but it's not known from Oregon or even Western North America at all. Mike has been looking for this for about 30 years. It was like a quest for him. And finally, a series of finds between 2010 and 21 accumulated enough material that he was able to convince some scientists that, okay, this is definitely Castoroides. And he's donated the material to them. A publication is now in the works, and it will be out hopefully soon. The material's on display at the University of Oregon. And the giant beaver, I sound like a broken record at this point, but it was the coolest animal. It was, yeah, 6 or 7 feet long if you don't count the tail, over 200 pounds. And the way this animal is often described is a beaver the size of a black bear. And that's a really effective and accurate description. I love it. But I'm growing even more fond of describing it as a beaver the size of a hippo. One, because it is technically the pygmy hippopotamus from Western Africa, but also because it's believed that this animal filled a similar ecological role to that of hippos. So this was basically our native hippo. And unfortunately, they probably didn't build giant dams. Their teeth were not sharpened and chisel-like modern beavers, so they were not adapted for cutting down trees or even eating woody vegetation. A combination of analyzing these fossils and some stable isotope analysis has told us that they probably ate a lot of wetland vegetation and aquatic vegetation. So no giant dams, but that does mean that these animals were not competing with each other for the same resources. So they could probably cohabitate very peacefully in the same ponds and wetlands. That's a phenomenon in ecology called niche partitioning, where you exploit a different resource to avoid competition. So these beavers were probably roommates. And this is an incredibly significant discovery, not just because of how interesting it is locally, but this map here shows every state and territory where we previously had material from Castorides. And as you can see, except for basically Alaska, it was all restricted to eastern North America. It was getting to the point where there was a serious question about whether these animals existed on the West Coast at all. Were they so aquatically adapted that they just couldn't make it over the continental divide? Well, now we finally have our answer. They were here. They were found in the Beaver State Forest. We have Mike Full to thank for it, and it's just a really, really amazing discovery. And this really beautiful museum replica here is incredibly evocative and lifelike, but there's not much size context in there. So I worry that if we leave it there, you might think it's just a beaver with a sinus infection and a rat tail. So let's peek behind the scenes where it was being built and give you a better sense of the scale of these animals. Our native beaverpotamus, confirmed in the Beaver State. Okay, so for time, I have to really fly over this section, but that's okay because there's unfortunately not a lot to say. Predators in general are much rarer in the fossil record than herbivores, both because of numbers. There's less of them than the things they're eating. That makes sense. And then even the biggest ones are not nearly as big as like a mammoth. Bigger things have a higher chance of preserving than smaller things, which will get picked apart and destroyed more easily. The most exciting things that have been found in the valley are some gray wolf skull material, a couple specimens that have been found. That is really cool, but without carbon dating them, we don't know for sure if they're Pleistocene or Holocene. So either way, there probably were gray wolves here in the Pleistocene. That's awesome, but they are an animal that still exists, even if they're not here in the valley anymore. So to talk about what kind of predators may have existed in the valley, we kind of have to speculate based on what we know from neighboring North America at the time. I found one record of dire wolf material from like 1979. Dire wolves they looked almost identical to wolves. They were a little stockier and slightly larger, and that's one animal that was probably here. Some other candidates would be 4 species of giant large cats, including 2 species of saber-tooth, the Smilodon and Homotherium, and an American lion, which was 25% bigger than modern African lions. In addition to these, there was the giant short-faced bear. This was the largest predator on North America at the time. Rearing up on its hind legs, it could get 10 feet tall, weigh over 2,000 pounds. Fossils of it are known from eastern Oregon, but as of yet, we haven't found anything in the valley. So another one that maybe it was here, but we can't confirm that yet. And these are just a couple maps of the known fossil discoveries of these predators. This is Smilodon, and that's the American lion. And all of them look pretty similar, different densities, but a really similar distribution pattern. And at this point, it's kind of getting weird that this area is just not turning up much fossil material of these animals. It might be a case like Castorides where we just haven't found it yet. That's the giant beaver. But I don't know. It's kind of seeming a little weird to me at this point. We'll have to do more research. And on that note, that's kind of a quick tour and overview of what was here in the Pleistocene in the Willamette Valley. Mammoths, giant ground sloths, enormous bison and camels and wild horses, probably some predators that we don't know for sure which ones, and of course the giant beaver. And discoveries like the giant beaver and the teratorn, that massive bird, those demonstrate that we still have a lot to learn about this area in the Pleistocene. There's a big horizon of discovery still out there. Are there other new species for us to discover? Could we finally confirm some terrestrial predators? I would be really interested to see if someone did an eDNA, environmental DNA study of some of those bogs. They could get a really comprehensive picture of what was here in the system. They could identify things that wouldn't have fossilized. That would be really interesting. Really fascinating to explore what caused some of the surviving species to leave the Willamette Valley. Why are they not here anymore? And again, personally, I'm excited about that because maybe that's restoration potential down the road. And then the other frontier of research that I think of is the subject of the rest of our talk, and that's the impact that these animals might have had on this landscape. That gets into a phenomenon called evolutionary anachronisms. We'll return to that in a moment, but first we have to address the elephant that's no longer in the room. We have to talk about extinctions. Now, this is one of the most hotly debated subjects in science, certainly paleontology at least. It gets like weirdly political at times and people really dig into their positions on it. I don't want to get bogged down in all that, so I'm going to just try and give a quick overview that hopefully kind of represents both sides in a balanced way. The two major candidates for what caused the extinction of megafauna are climate change and human impacts. And both of these things are phenomena that we know for sure were occurring at the time. The last glacial maximum was 20,000 years ago, and then they started melting and retreating, which caused tons of climatic changes. The Earth warmed by about 3.5 degrees over a couple thousand years. So that was definitely happening, and we know from today climate change is a serious pressure on organisms. Also, there was a new super predator on the scene, and that was us, that was humans. And I don't just mean here, I mean all over the world. And we know for sure that they did hunt and use these animals because we found fossil remains with very clear signs of butchering and processing. So the question is, which of these pressures was enough to cause them to go extinct? And it's kind of simplistic in my opinion to say it must have been one or the other. Life is really resilient, and it's really hard to cause something to actually go extinct. Think of everything we've tried with salmon, for example, and they're still hanging in there. But it's usually an aggregation of pressures that causes an extinction. It's not one thing. Megafauna had survived several interglacial periods, which would have had a similar climate change long before humans ever showed up. But at the same time, we know that humans coexisted with these animals in the systems when they did show up for a period before they went extinct. It wasn't just a tsunami of teeth that arrived and everything dropped dead. Again, that could be a whole nother talk. Suffice to say, it's probably a combination of both pressures, and the discourse is slowly moving in that direction as well. But I'm more interested in talking about the consequences of their extinction, because as I said at the beginning, these animals vanished moments ago, ecologically speaking, evolutionarily speaking. There's tons of examples out there of organisms that had relationships with these animals that don't have a partner in that relationship anymore. And this phenomenon is called evolutionary anachronisms. A couple examples. One of the most famous ones is the Joshua tree, which is an arborescent yucca plant from the southwestern United States. Its large fruits, which are a big investment for this plant to make, were likely eaten and dispersed by megafauna, for example, like the Shasta ground sloth here, which is another species of giant ground sloth. A really big study came out in 2011 that was kind of mapping the change in distribution of this plant. The dark polygons are the modern distributions. The large hexed polygon is the estimated Pleistocene distribution. Yeah, and the triangles are fossil remains that they found, which helped them make that prediction. Even in 2011, when that study was published, the southern populations were starting to crisp up and respond to climate change. And you would expect a plant to start to shift its range north to more palatable climates in response to that. But because their primary mode of seed dispersal is gone, they can't really do that anymore. It's much harder for them. And so this plant and the ecosystem that it helps define is under increased pressure in addition to everything we're throwing at it today because of the absence of these animals. I was hoping to find examples of this local to the Willamette Valley. To my knowledge, there haven't been any studies on that yet, but I don't want you to think that that's just a somewhere else problem, because remember, in nature, everything is connected. Those Joshua trees in the Willamette Valley are all along the Pacific Flyway, which is a hugely important migration corridor for waterfowl and other birds. Birds that we probably love here in the Willamette Valley are likely using the Joshua trees as a resource on their migrations. And as we just spoke about, extinctions are usually an aggregation of pressures, and this is one additional pressure on these organisms. It's not just Joshua trees, there's tons of fleshy, large-pitted neotropical fruits where megafauna were very likely the primary dispersers of them. Avocados are the most popular examples. Just try and imagine a rabbit eating that and trying to disperse the seeds. Sounds painful. But megafauna would have been great at it. There's been an increasing number of studies demonstrating this. This one here was exploring how far animals could disperse the seeds, and as expected, the extinct megafauna were the champions there. And it's even observable in surviving ecosystems. There's trees in Southeast Asia where the fruits are eaten by tons of animals, but Asian elephants eat only about 3% of the fruits. And in spite of that, they're responsible for over 1/3 of the successful germinations of those trees. But on the other side, away from dispersing an organism and to controlling it, this is the creosote bush, which is another native to the southwestern part of the US. This is a wonderful native shrub that supports a lot of insects and pollinators. It's incredibly drought adapted. In fact, it's so efficient at absorbing water that seeds of other plants that fall next to it can't absorb enough water of their own to germinate. So you get vast stretches of the desert that are dominated by this shrub, which again is a great shrub, but it's not a very diverse system, and a lack of diversity is a less resilient system. If you think about what makes an invasive species invasive, you know, part of it is it doesn't provide a lot of services to native organisms, but it's also partly not controlled by many organisms. So what's interesting about this one is that the American Army in the late 1800s did an experiment where they were testing out pack animals that would be useful to them in this region of the country. And they imported a bunch of Arabian camels. And those camels started happily munching on the creosote bush. It's a very bitter plant. Almost nothing eats it. Jackrabbits might if they're starving and you held a gun to their head, but basically nothing else except the camels that they imported. And it's thought that the American camel would have been the primary herbivore that helped keep this organism in balance with the rest of the ecosystem. This one's just really interesting to me. The pronghorn is the second fastest land animal on Earth. It can reach speeds of 60 miles an hour, which is absurdly unnecessary because nothing on this continent can catch that. But there used to be something that probably could. We had an American cheetah. That was the fourth of the big cats I mentioned earlier. It wasn't very closely related to African cheetahs. It was more closely related to mountain lions, but it convergently evolved similar adaptations for speed. And it is believed that this animal is what pressured the pronghorn into becoming so fast. However, that is still up for debate. There's still active research going on into whether that's true or not. It's pretty plausible and it's increasingly supported, I think. Now the last one is not a species to species relationship, but it's an entire ecosystem. In the Pleistocene, the largest biome on the entire planet was something called the Mammoth Steppe. And that was an ecosystem in the Arctic that was a massive, diverse, and highly productive grassland inhabited by a wildly diverse and abundant collection of megafauna, including the woolly mammoth. Now this was a huge carbon sink on its own, but all that carbon was stored in the soil in part because of the permafrost. Permafrost freezes the decomposition and the release of carbon gases. And it's believed that in the Arctic today, something around 1,700 billion tons of carbon are locked away in the Arctic permafrost. Reference, that is roughly equivalent to half a century of human-caused warming equivalent. So this is like a ticking climate bomb that is threatening to go into a vicious cycle of warming where our warming thaws more permafrost, that releases more carbon, increases warming, et cetera, et cetera. But if the megafauna were still around, it probably would not be an issue because when they're grazing through a landscape in the winter, they compact all the snow that they're going over. Snow is a really great insulator when it's piled up. And so when they compact it through just existing in that system, cold can penetrate deeper into the soil in the winter and refreeze the permafrost and make it more resistant to thawing and melting in the summer. And when I say it was the biggest ecosystem on Earth, that's what I mean. It was 10% of the terrestrial surface at the time, and it now survives in a couple remote valleys in Central Asian mountains. So, can we talk about what effect megafauna may have had here in the Willamette Valley? Again, to my knowledge, there's no studies of this, but we can do a little bit of speculation based on educated guesses built off of what we know living megafauna do. So we'll just go through a couple of those real quick. The first one, many of you have probably heard that indigenous fire management practices before Euro-American settlement are what led to the open grasslands and savannas that kind of characterize a lot of the Willamette Valley today. It's very plausible, I think, to hypothesize that megafauna may have been having a similar functional effect before those practices would have started, even further back. Tree felling is a known behavior for modern elephants. Studies have shown that in parts of the African savanna, tree fall is 6 times more common when elephants are present than absent. So think it's a reasonable speculation to make that they may have been doing the same thing here and maintaining these open systems, which would have led to the grassland that one study found was present in the system at the time. It wasn't restricted to open habitats. African forest elephants do this too. In Central African rainforests, the knockdown of small and medium-sized trees allow the big ones to get even bigger and store more carbon. Like a 1-to-1 ratio, that leads to an increased carbon storage potential. And again, that could very easily have been happening here too. Megafauna could have been enhancing or maintaining what is already one of the greatest carbon storage potentials of any forest in the world today. And then there's lots of spin-off questions that could happen from there, like would that have altered fuel loads and affected wildfire regimes and things like that. For the last one, of course, we have to close on beavers. We know today that beavers are ecosystem engineers. The dams they build pond up a ton of water and recharge aquifers and engage floodplains, create habitat, all kinds of awesome stuff. It's very likely that the giant beaver would have been using those same ecosystems, those same ponds. But recall that the giant beaver was coexisting instead of competing with these beaver, and it's believed to have filled a similar role as hippos. Hippos are keystone species in Africa today. They are known to widen rivers and expand floodplains and wetland habitats on the margins, maintain connections to slow-moving side channels. And if the giant beaver was filling a similar role, it's easy to believe they could be doing the same thing and compounding the effect that modern beaver have. They could breach vegetation levees and keep floodplains engaged. They could keep side channels excavated essentially so that they don't become entrapment dangers for native fish that are taking refuge in there. Again, no studies. I have to emphasize this is just speculation, but it seems plausible based on what we know about these animals. Okay, so in conclusion, the point of all this is just to hammer home how important what we do in this lifetime and in this century is. If the loss of animals, almost 12,000 years ago is having consequences that are still being felt today, imagine what's going to happen if we lose beavers or salmon or anything like that. Our actions are going to be detectable in the fossil record for millions of years. If you're worried about legacy, I can't think of a longer lasting legacy than that. Every yard you turn into a native landscape pollinator refuge, every native tree you plant, every dollar you donate to a watershed council or hour you volunteer with one, it really makes a difference. We are going to decide the direction that the evolution of life on Earth takes from here on out. It's a big responsibility, a mammoth one perhaps, but it's also a joyful one. Anyway, thank you all so much for coming out.